Hey everyone, welcome to your very first set of video notes. The goal of these notes is to try to preview the lesson before we go over it in class, essentially. So it would be optimal to have the notes in front of you and to copy them down as the video goes through them. So pause the video at any time to write down important information, to jot down any questions that you have that come up while you're listening and watching so that when we're together in class again, I can answer those questions for you. So I'm going to try to keep these notes really brief, 5 minutes or less. So let's see how we do. Today's topic is about the definition of function and function operations. What we want to be able to do by the end of next class is to be able to use function notation, be able to identify what is a function and what's not, and to combine two or more functions using our basic math operators of addition, subtraction, multiplication, and division. So a lot of this should be a review from previous years. A relation is any set of ordered pairs. So any two data points that are related to one another would be considered a relation. So we think of these often as x's and y's. A function is a specific type of relation where for every x, which is also known as an independent variable or an input, corresponds to only one y value or dependent variable or output. A way to think about this graphically is that it passes the vertical line test. So if you remember, the vertical line test is if we scanned a vertical line across our entire graph, it would only touch our function in one place at one time. That means for every x value, and the x is our vertical line, it's only touching one y value. Okay. So relations can be represented in a lot of different ways. Ordered pairs are a very common way where we have an x paired with a y inside parentheses and separated by a comma. We can also write a relation or, of course, a function as a set. A set is just a listing of ordered pairs, but it's inside these symbols, which are called braces. They're kind of like squiggles. A mapping, if you remember, oops, and this is going to be hard, is a set of two ovals. One oval is your independent variable, the other oval is your dependent variable, and you list out in order all of your x values, and you list out in order all of your y values, and then you draw lines to show which ones are paired together. So you'll notice that the y values only have 3 numbers in there, and that's because the 4 is a repeated y value. So you don't include any repeated values in a mapping. You just indicate a multiple values by drawing the arrow to the correct point or the correct corresponding value. And they're also always in number order from smallest to biggest, or the most negative to the most positive. A table should be fairly self-explanatory. We have an X column and a Y column, and the most basic type of table is a T-chart. We list out all of our X's, and we make sure that they're paired up with all of our Y values. If I could find where I put these. Okay, and then a graph is a final way to represent a relation. You just plot them on an XY coordinate. So we had a point at 1, 0, a point at 2, 4, a point at -3, 4, and one at 5, 2. And hopefully we remember that. Oh, I don't know where this point is. I swear it was there. But go ahead and just draw in a quick point there really fast. It's going to be hopefully kind of neat. Okay. All right, I'm starting to run over. We're going to do all of this in class. So the last thing I want to talk about is the way that we can combine functions using operations. Like I said, addition is literally when we add two functions. This is what we call function notation. And so if we combine two functions using addition, that's one way to combine them. We can also combine them using subtraction, multiplication, or division. Sorry. There we go. This one is going to come in kind of weirdly as well. Okay. Now, the one thing to be careful of is when you combine functions using division, oftentimes you'll end up with a variable in the denominator, and our denominator is not allowed to be equal to 0 because we get an undefined function there. So there is always a restriction on a domain whenever you have a variable in your denominator. And so we'll talk more about that, how to find that restriction. But it's basically whatever value of the denominator, I'm sorry, of the variable that would make the denominator equal to 0 is your restriction. And the rest of these notes we'll talk about in class. I went a little bit over today, but like I said, I will try to keep these notes to 5 minutes or less. Make sure you let me know if you have any questions in class, and I will see you then.